Question 7. Figure 2 shows a sketch of part of the curve C with equation y equal to x cubed minus 10x squared plus 27x minus 23. So point P, 5, -13 lies on C. And then the line L is the tangent to C at point P. So part A, use differentiation to find the equation of L and then giving you answer in the form y equal to mx plus c. Okay. So to find equation of the tangent, so first thing we need to do is differentiation. So dy over dx is equal to 3x squared minus 20x plus 27. And then to work out the gradient of point P, you just substitute the x value into the derivative. So x is equal to 5. So if we substitute in 3 times 5 squared minus 20 times 5 plus 27. So put that in the calculator. 3 times 5 squared minus 20 times 5 plus 27. That's just equal to 2. And then because it's the tangent line we're looking for, so the tangent line has the same gradient as the point. So we can just use 2. And then we can just do y equal to 2x plus c, and then substitute in the point to work out c. So when x equal to 5, y equal to -13. So if we substitute in, -13 equal to 2 times 5 plus c. And -13 equal to 10 plus c. So c is equal to -23. So therefore, the equation is just y equal to 2x minus 23. Okay. And then hence verify that L meets C again on the y-axis. So basically, we want to show that they both have the same y-intercept, which is quite obvious. So for the line L, when x equal to 0, y is equal to -23. So then 0 and -23. And then for the curve C, when x equal to 0, so y is equal to -23, because 0 minus 0 plus 0 is just 0. So -23 is just -23. So 0 and then -23. So therefore, same y-intercept means L meets C again on the y-axis. Okay. Part C. The finite region R, shown shaded in figure 2, is bounded by the curve C and the line L. And in part C, one has to use the algebraic integration to find the exact area of R. Okay. So if it's finding the area, it has to be something to do with integration. And then for this point, we know the x value is 5. And then for this one, that's just 0. So if we integrate the curve between 5 and 0, so remember, integration is trying to find the area between the curve and the x-axis. Yeah, so it's between the curve and the x-axis. So this is a curve, and then this is the x-axis. So if you want to find if you do the integration, the area you're going to find will be this area. But be careful, since it's below the x-axis, you'll get negative once we've done the integration. So you need to make it positive because this is the area. Yeah. So, but we're looking for the R. We don't want this area. So what we should do is we need to work out the area of this trapezium. And then once we work out the area of this trapezium, we can just minus the area of the blue part. Then that'll be the region we need. So we need to find one by one. Okay, so I'm going to start the trapezium first. So we know this length here is obviously 5 because x coordinate for that point is 5. And then because it's 5 -13, so that means this length should be 13. And then we know the y-intercept is 0 and -23. So if this is 23, that means this length here is 23. So then to work out the area of the trapezium, then that will just be 13 plus 23 over 2. So the average of the two parallel sides for the trapezium times by the height, 5. That would be the area. So 13 plus 23 over 2 times by 5. So that would be equal to 90 for the trapezium. And now we just have to integrate the curve between 5 and 0 to work out the blue area. So if we integrate between 5 and 0 for x cubed minus 10x squared plus 27x minus 23 dx. So then that'll be plus 1 to the power divided by the power. And then plus 1 to the power divided by the power. And again, plus 1 to the power divided by the power. And then minus 23x. And then between 5 and 0. So substitute in 5, we have 5 to the power 4 over 4 minus 10 over 3 times by 5 to the power 3 plus 27 over 2 times 5 squared minus 23 times by 5. And if we substitute in 0, it's all 0. So we just put this in the calculator. So 5 to the power 4 over 4 and then minus 10 over 3 times 5 to the power 3 plus 27 over 2 times by 5 squared and then minus 23 times 5. That is equal to negative 455 over 12. And again, the reason we get negative is because this region is below the x-axis. Yeah, so we need to use the positive number, the absolute value, 455 over 12. So now we just have to use the area of the trapezium. So the area of the R is equal to the total area of the trapezium minus the area of the blue part. So that would be the answer. So 90 minus 455 over 12. That's just equal to 625 over 12. So that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.